Good morning, or just into the afternoon. Good afternoon, everybody, and welcome to this IAgrE lunchtime lecture. A special welcome for our colleagues from Engineers Ireland who join us today. Really great to have you with us. In a moment, I'll just introduce our speaker. Just to say at the end, after our speaker's finished his presentation, put your questions in the chat, and what I'll ask you to do is, in turn, read your question out so that we've got it for the recording. Okay, so a very, very warm welcome to my friend Andy Littler, and I think we're in for a treat on quarry restoration. Andy's a chartered mineral processing engineer, has a long and very successful career in the quarry industry, and he's a member of the Institute of Quarrying. And within that, I gather he's the go-to person on biodiversity management within mineral workings. So we've got the expert with us today, and I'm looking forward very much to Andy telling us all about how you should increase biodiversity in working and historic mineral sites. So over to you, Andy.
Well, thanks for the introduction, Mark. Just to add a couple of things to that, I've customized this presentation on the basis that I'm talking to engineers. So I've put some slides just on quarries and quarry planting. And equally, if at the end of the presentation you want to ask me anything about quarrying or sports turfs materials, I run a company for silica sands once, then fire away. So this is a little bit different, but sort of imagine yourself for the next hour as a quarry manager who I'm trying to inspire to do a better job of recreating habitat in some cases in their quarries or extractive sites. So what we're talking about today is restoration and biodiversity. You'll hear me use these expressions a couple of times. Restoration is the process of giving quarried land a useful purpose after quarrying. Could be agriculture, forestry, recreation, housing, of course, farmland, or other development to a nature reserve natural habitat. And in most of these cases, biodiversity can be increased. Biodiversity is just the variety of plant and animal species living in their natural environment. Now, why am I fired up about this? Why does this interest me? Well, I could give you a whole load of figures about we've lost 90% of wetlands since the Industrial Revolution, 97% of wildflower meadows, 78% of flying insects have gone since 2014, according to Unkempt Wildlife Trust. But I like this slide. This slide's from an excellent book, The Book of Wilding by Isabella Tree, based on her work on the Knepp estate in Sussex. This is Key West, sport fishing, 1957. Look at the size of those fish in 1957. Look how they've declined over the years and what they are bottom right. And that is the state of nature, fellows, I'm afraid. We've lost so much biodiversity, its abundance, and the number of species. And I just think that's a very graphic slide, even if it's a bit off message for that. So why do mineral sites offer such potential for increasing this biodiversity I'm talking about? Well, because you're working a rock which is unique for a purpose, be it limestone or sandstone or igneous rock or sand and gravel, silica sand, it often has a pretty unique geology, acidic, alkaline, free draining. And that in turn creates these unique habitats, heath, calcareous grassland, etc. So that often starts with a very interesting flora and fauna. The topography's obviously uneven, and nature likes that. Nature doesn't really like flat. It likes undulations. It likes wet areas and dry areas and cliffs and screes and all sorts of things like that, because different plants and insects are adapted to those things. The soils are often thin, they're often nutrient poor or historically absent. And sometimes because quarry managers have buried them or sold them, to be honest. This allows flowers to prosper at the expenses of grasses and more ruderal plants that need more nutrients. And we'll come back to that. Wet and dry areas I refer to suits different flora and fauna. They're often remote locations. You've not got much human interference. And then last, certainly not least, planning conditions. Sometimes planners will see this as an opportunity to create natural habitat in an area and put conditions on it. Cash available from the operator. Quarrying's a lucrative business, and they will be putting aside so many pence per ton. They work through the life of this quarries to restore it during and afterwards. So again, why do I get interested in this stuff? Well, on the left-hand side, we see an agricultural field. I appreciate I'm talking to agricultural engineers. We've all got to eat. I'm not against agriculture. I like my meat and milk and cereal in the morning. But the field on the left is not attractive to pollinators. Right, so we're going to swiftly head to the Derbyshire Peak District as a nice simple example of a quarry which has been altered for the benefit of nature. Now, this is a straightforward quarry that was finished in the 70s. It's carboniferous limestone, probably the most important economic mineral in the country, and it was just left for about 30 years. Nothing happened to it whatsoever, and then we decided to get together with another two parties, with Derbyshire Wildlife Trust and with Butterfly Conservation, and make this into a small nature reserve. It was already very, very good for butterflies, hence the background. You can see all the scrap top right, you can see the parties on the left-hand side. Now, we talked about very thin soils. You can see on the right here, that's almost a limestone pavement. There's really no soil on that at all. But this is marvelous for wildflowers. That you see there: wild marjoram, harebells, birdfoot trefoil, Lodi's bedstraw, thyme. Really, really good for wildflowers, which in turn attracts the butterflies and the basking. And these are some of the species seen here. You've got the butterflies, the common blue, the common, the large skipper, and the wall brown top right. The wall brown has declined 80% in the last 40 years, and they love basking on southern-faced bare rock. That's their thing. So it's been very well recorded by butterfly people, and all these things have been spotted. So we've done a number of things at this quarry, which are fairly straightforward, really. First one is get the wildflower seeds going in other places. This is a bank which protects a fall, a cliff on the other side. You can see the sign on the left-hand side. And what we've done with that ugly bank is we just covered it in some sort of dust with clay content, limestone dust, and seeded it with a calcareous grassland seed mix. And all those same flowers are coming up the next year. Fabulous, and have continued to do so. And you can see the species I was describing earlier there, and that's been done on any of these banks around the quarry. The next thing, any nature reserve, get some water, get some ponds involved. Always good. Amphibians, birds feed there, different set of aquatic plants. On the left, you can see this pond as was. It's a dew pond that had completely overgrown, full of willow and whatever. It was dug out, properly clay lined, pitch stones. Brilliant job made of it. Probably cost about £7,000, but like I say, quarry companies have got money. And within a couple of years, absolutely teeming with newts, great crested included. And the post on the right is by a chap called Chris Monk, who is the amphibian recorder for Derbyshire County Council. So as influential as guys you're going to get on that, who is, you know, celebrating the amphibian life of that pond. We talked about butterflies. Now, quarry people, probably like agricultural engineers, are motivated by objectives and lists and targets and things like this. We quite like that. So what we've got here is the Hogue Range butterfly list. As I say, this has been recorded over many years. This goes back to 2015. So we've got 32 species are found on this site. There's only 59 in the whole of the UK. So that's pretty impressive. And the abundance and the number of them is going up. And in order to facilitate that, we've actually done some specific planting. So we planted holly for holly blue, and we've planted the buckthorns for the brimstone butterfly, and the elm for white leather hairstring, and they've all come. Okay, going on to a bigger quarry now. This is Mansetta Quarry at Nuneaton. Still hear me, Mark? But, yeah, this is Mansetta Quarry at Nuneaton. Very interesting geology. What you're looking at there on the right-hand side is this sort of footwall of what's called a dipping sill, a volcanic sill, but a sill happens within the earth rather than on top. And that dipping sill is this very skid-resistant stone used for the surface of the roads. And this is it in 2001, the point at which I, along with other people, wrote a biodiversity action plan for the quarry, and as to, you know, what would happen and what we'd encourage and how we could facilitate things, you know, into the future. This is Mansetta Quarry, and we're going to see a series of slides here. That's what it looks like in 2019. So if I toggle back, okay, this is how quarries progress. And you can see on the right and left-hand side, all the overburden being the non-rock usable rock, has been piled up to be replaced on the slopes at a later date. And you can see down here the actual quarry itself with the excavator and a shot pile of rock. So that's what it looked like. And keep an eye on this stuff here. This is the sort of overlying shale, also the overburden, and that's what we're going to be using for restoration. I'm just going to digress now because you're engineers, and I just think this is a great slide. This is that rock to a geologist. Now, if you thrust a pebble or a bit of rock into a geologist's hand, he's not going to be as excited as if he could cut it into a very thin section and put it under a microscope in cross-polarized light, and that's what it would look like. So that's how you identify, you know, a dolerite with these plagioclase and pyroxene and olivine crystals. Digression, but a colourful one. And that is not Mansetta Quarry restored. It's one over the road. It's the same formation, just with a little public highway between. And you can see where the overburden has been folded back in, shaped, lakes at the bottom, some woodland planted on the right and left. This has got more work to do to compartmentalize it and get it into some sort of semi-productive agriculture. But it just shows, you know, that becomes that, hopefully. Okay, so staying at Mansetta, I've talked about these very nutrient-poor substrates. This was the Jubilee tip, no prizes for when it was started. And this is us reshaping it in 2004. This is incredibly acidic because what happens with these overlying shales is they've got pyrite in. When the pyrite is exposed to the air and water, then you get sulfuric acid forming. Some of the pools in this had a pH of 3.5. It has to have a little bit of friable material to root into. You get a sort of an eye for it. It's not actually pure rock. It's something that's weathered enough to make it rootable. But that is, in this case, an acidic grassland. Suite of flowers has been planted. There's a lot of bird's foot trefoil there, and oxeye daisy, and the red clovers, etc. And this is it, 2013, 12 years on. The blue plant is one of my favourites, Viper's bugloss. You've got a lot of mallow there, a load of the bird's foot trefoil again, which is a legume, putting nitrogen back into the soil. So we're getting this wonderful array of wildflowers on this very, very poor soil. And that's it very recently, 2023. Close up, iPhone cameras have got better. It's full of ragged robin, hedge bedstraw, Jabanda speedwell, cowslips, primstows, salad bonnet. You know, actually in a quadrat, there's probably about a dozen species here, which is very, very good indeed. So we'll move on to Carboniferous limestone now. This is Balladon Quarry. Going back to the Peak District, all these quarries are ones I was the manager or area manager or of, you know, back in the day. So this is Balladon Quarry. Balladon Quarry is an industrial limestone quarry. Limestone incredibly useful for animal feeds, for ceramics, for glass production, for fillers and adhesives. You know, it's used for all these things in fine powder form. And we're going to talk now for about 10 minutes about the slopes on a quarry, the sides, because this is the elephant in the room. You know, potentially a quarry side is ugly. You know, you've hewn a whole block out of the earth, and you're seeing the and in truth, there's not an awful lot you can do about that, other than particularly near the top of the quarry, where, you know, walkers might be seeing it, where you want it to sort of merge into the landscape. You can try and soften the effect of that. So what we're seeing here is some of the work under the auspices of another biodiversity action plan, hatched about 2000. On the left-hand side, you're looking at rock being placed on the ledges, what we call the benches, very thin covering of soil all mixed in, and then planted with trees. Planted with trees because if you don't plant with trees, you'll never access these again. If you don't plant them with trees, you'll just get sycamore coming in, or birch. You won't have any great variety. You could argue that's rewilding after a fashion, and it will settle down. But if you want it to be biodiverse earlier than that, then you would do that. And again, this is just a bit innovative. On the right-hand side, you can see we're actually planting these from a man basket because we weren't on the case early enough. So you can see the trees again going into this very poor quality soil. Trees will grow in poor quality soil. They'll grow better in good quality soil. What they don't like is compacted soil. They really don't like it at all. So if you can loosen things up, make sure you haven't run over it with heavy equipment. And here's the progression on that. The tree planting we were looking at is on the left-hand side over here. And you can see it's all grown. We've got this thing called a rollover, where we're rolling over the surrounding landscape into the quarry. That's grazed, so you can manage that. And then the picture on the right-hand side, you're seeing that 6 years later, we're now piling up quarry waste, of which there's a lot in the industrial limestone quarry, up against those spaces, again, you know, to soften the thing and make something you can graze and that's manageable. It's the other side of the quarry. Again, this is 6 years on from a slope like that. Just what we would call scalpings. Things are growing. Scalping, to take the head off, is the first process in quarrying. You run all the rock over a 40mm or a 75mm screen and take out what is the weak, fissile rock, clay, small particles, which tend to have, you know, more nutrient, more ability to absorb water in there. So that's 6 years on. And in fact, in this case, the seed mix has had a lot of legumes in it, a lot of nitrogen fixing plants to try and give it an early boost. And you see some tree planting here, and we've got the contrast here of screes and bare rock, because in creating a biodiversity action plan, we looked at Peak Park's biodiversity action plan. They list a whole load of things that they're short of, like scree slopes, hay meadows, ash woodland, wetland, and we've tried to ape that and replicate it and increase it. So dealing with rock faces. Again, imagine you're quarry managers and I'm trying to encourage you to do a better job. On the left-hand side, a straightforward slope. At the bottom, this thing here, the toe of it is a safety feature to stop rock tipping off the side of it. And you'll get some growth in there over time, for sure you will. But if you can put some rootable material behind that safety feature, and if you make some nooks and crannies up along the rock face, which will trap some sort of subsoils and whatever, it's going to go green and be a lot more interesting a lot earlier. Okay. This is one I was involved in at the end of my career, a wonderful company called Longcliffe Quarries. If you're agricultural engineers, you may have heard of them. They supply agricultural lime in Derbyshire and agricultural feeds all over the limestone into them all over the country. And what we're looking at here, okay, I get a bit of an anorak on these things, but if you look at the area circled, this again is a rollover. This is right next to the Peak Park. Up here is the Peak Park, very sensitive area, Peak District National Park. So what we're doing here is we're taking a slope down into the quarry, and then as we go down into the quarry, we're creating crags and scree slopes and bench planting to soften the whole thing at the top of it. And you can see that's in this area here, and that's what it looks at. Look at it now. If you look on the right-hand side, what I'd like to suggest is if you didn't know that was a quarry, would that look like a dale side in the Peak District? I'd suggest it does, and that's the intention. And all this can be grazed, obviously. This is another one of these rollover type features. This is going back to Balladon Quarry. Really, really proud of this one. Now, the whole of this, if you see the cursor line from top to bottom, the whole of that is a quarry face, rock face. But if you look, we've got scree slopes, we've got faces, we've got crags, we've got individual boulders and planting. We've got it merging into a sort of soft slope here. We've got planting on the benches. Again, we're trying to get this dale side feature, and the Peak District is great for biodiversity and the dales. And if we can replicate that, it's going to work. Okay, so we've had a look at quarries. We're going to have a peek at some yellow metal. Okay, can I have a thumbs up again, Mark? You can hear me, right? Yellow metals, what quarrymen call the excavators and the diggers and the dump trucks. And I'm guessing you as agricultural engineers are involved in this. In fact, I asked someone the price of a tractor they were operating the other day. I was absolutely shocked. It's about £250,000 or more. You're probably going to say that's a cheap one. So what equipment do we use in quarrying? Well, if you're talking about overburden, years ago, it used to be box and scrapers, towed by a bulldozer with a box, or the actual scraper itself on wheels moving a lot. They were great at the job, but they weren't nearly as versatile, and particularly in bad weather, as this method. Because these fellows came along, articulated dump trucks, or bendies, as we call them, and an articulated dump truck can work in really terrible conditions on really bad underground, underfoot conditions, and pretty well year round. And they can be engaged in small jobs, big jobs, or whatever. So, a combination like this, something like that size of excavator and 3 or 4 dump trucks, move maybe 1,500, 2,000 cubic meters a day of overburden, and very versatile way of doing it. This is a bulldozer. You probably need a bit bigger one to do any real work, but this is a model. I bought the first D11R that came into the country, and these are used to rip. This ripper at the back here is pulled through rock, particularly the bunter pebble beds in the Midlands, and it's pulled through, and it gets very, very hot, and it's quite noisy. But a single pass, you pull through it, you loosen the rock, and then you use the front of the bulldozer to push it over the face, and picked up by a loading shovel and put into a field conveyor usually, or maybe dump trucks. So again, commonly used bit of kit. This is excavators used to be drag lines. If you're familiar with the drag lines, the rope drag line, the Ruston Busaris boiler, the RB, 30 and 38 and 61, etc. Drag lines have gone now, really. They're a bit slow, and two, you just cannot get the skilled people to operate them. It's very, very difficult to operate a drag line well. Whereas these things, the hydraulic excavators, they've developed them with a longer and longer reach, so you can actually work underwater with them. And this is a specialist company that does just that. Another method of working, which is surprisingly common, would be various sorts of dredgers. You float a machine out there, you put down a suction head, usually with some sort of cutter on it, and you cut away at the bottom and suck it up and pump it to shore to a process plant there. Those spud legs can anchor it if need be. You can also anchor it using wire ropes onto the bank. So, actual getting the rock out of the ground, fairly, well, I'd regard it as straightforward. You drill a hole, sort of sub-vertical in the ground. You drill lots of them, and you stuff them full of explosives. And this is a machine that's drilling the holes. They're pneumatic. It's what's called a down the hole rig. So the actual drill head is down the hole and pulsating down the hole, not at the top. In the same way as a masonry drill works. A masonry drill isn't actually screwing out the material at all. It's just going bash, 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 and turning very slowly. So there's a new thing there. And little tungsten carbide buttons do the bash, bash, bashing. And then it sends up dust up to the top, and on you go. And if you're drilling through limestone, one of these bits will last for weeks. If you're drilling through sandstone, gritstone, much, a 50th the life. It's drastically different. Free silica is deadly to metal. So you drill these holes at a slight angle, and then we pump them full of explosives. I used to do this back in the day when I was training, and it's great fun. At the end of the day, you press a button and the earth moves, and you push the rock forward. It's very controlled explosion. The detonations are set sort of microseconds apart in a pattern, so that you blast the middle out and then the further out and out, so that you don't cut the blasting wire from your first detonation. And that's a blast going off, and hopefully it looks like that. It's a nice clean blast. You can see the back wall, and it's ready to be loaded out with a loading shovel. Let's have a look at a couple more bits of kit. This is the back actor excavator loading a dump truck. Again, this is the typical way of doing it. I'm 70 this year. I started in the business when I was about 21. You'd have never seen this. Putting a track machine on top of a load of rock pile. Absolutely not. You'd load it from the base with a face shovel that went like that, or with wheel loading shovels. But the great thing about this is it's very safe, because you've got no chance of the rock tumbling down on top of you, and also you do other things with that excavator. Very versatile, and that has become the main way of doing it. And I wouldn't have dreamt that when I started in the business, I must say. This is kind of thing that it can also do. In this case, it's scraping back at the face to make it safe. So rather than loading rocks, it's making it safe for the next time around. Let's talk about a bit of filthy lucre. This loading shovel here, 1.5 million at the moment. About 1.5 million. The dump truck, about 1.2 million. Now, if you go to Tunstead Quarry up in Derbyshire, biggest in the country, 7 million tonnes a year. They've got 2 of these and about 8 dump trucks shifting about 20,000 tonnes a shift, 7 million tonnes a year. So that loading shovel is picking up 25 tonnes. The dump truck is receiving 100, so 4 passes and it's off. So, you know, say it quickly, picking up 25 tonnes, biggest truck on the road, the Arctics, will take about 29. So it's nearly filling one of those in one pass. Here's a quarry plant. This was Longcliffe, and quarrying, aggregate quarrying, is really a process of comminution. The cheapest comminution, reduction in size, is blasting. You're blasting it down to pieces, you know, a metre and less down, and then you put it through a primary first crusher to knock it down to smaller size, take away, a bit like a garden riddle, take away the small stuff and use that, and then crush the bigger stuff, a series of crushers. And you'll start off, in this case, at about 600 tonnes an hour, and you'll end up with the very fine grinding machines at about 6 tonnes an hour. It all depends on the size. An immense amount of energy it takes to do the fine grinding in the end of the day. Quick whiz through crushers for you engineers. This is a jaw crusher. This is a very common type of rock crusher. In a jaw crusher, you're overcoming the compressive strength of the rock. Simple as that. You're overcoming the compressive strength of rock. So you have one of these jaws is fixed with a big wear plate on it, and one goes in and out on an eccentric shaft on the end of a big flywheel. So eccentric shaft gets a sort of motion like that. And probably the commonest crusher is a thing called a cone or a gyratory crusher, which is essentially this in 360 degrees. The other method of crushing is an impact crusher, where you overcome the tensile strength. And in this case, it's a bit like taking a rock and hurling it against the wall. Take a rock, hurl it against the wall, and it shatters, except you're doing it, you know, at huge speed with a lot of power behind it. Great thing about the strength and weakness of an impact crusher is it makes a lot of dust. So if you want a lot of dust, they're great. If you don't, they're not good. And if you're dealing with a rock with a lot of silica in, they're not good, because they'll wear out very fast indeed. Then you get to even finer comminution. You have a load of balls milling around in a tube, and you rotate the tube, and the fine material is ground between the balls. This is incredibly inefficient mechanically. You know, probably only 4 or 5% of the energy you're putting into this thing is actually being used for crushing. Most of it is being used to drag the balls through the mill and cascade them or whatever. That's the sort of physics behind it. Okay, well, after that interlude, back to work. And we'll go to God's own county of Dorset and have a look at, we've been through some rock quarries. We'll look at some sand and gravel, in this case, sand. So this is a sand quarry in Dorset. It's an area project I'm working on at the moment, keeping my brain going in retirement. And this is an old sand pit in the Eocene bagshot beds. It's sand, but there's a lot of clay and silt interbedded, and that's it when it's worked out, in effect. So we're going to try and make this into something from that. So we'll do a survey of the site to see how much volume is needed, what sort of slopes we'll get at the end of the day, how we'll design that, and then we'll use an earth moving plant to push that up around the place roughly, and try and mimic a more natural landform. We want some steep slopes and faces for nesting sand martins and mason bees and things like that, but in the main, we're trying to produce an undulating, in this case, heathland. And then at the top of those slopes, you can see where work has been done to create wet areas and dry areas. And then these have been spread with heather brashings. The heather brashings are absolutely ideal for recreating heathland because they've got all the seed in them, but they also provide a microclimate for the heather to germinate underneath. And heathland is actually quite easy to recreate, believe it or not. I mean, the purists will say it isn't because it hasn't got the soil profile and a proper heathland. But in actual terms of what flora and fauna live on it, you can do a pretty good job pretty early on. And we see down below here, we've got this slope with the heathland grasses, the Molinias and heathers and gorse, and then we've got some faces here for the sand martins, etc. This is just an example of any quarry is going to have a restoration plan, and it will have huge files of documents on surveys beforehand and afterwards, how you should move, earth, and profiles and what you're looking for at the end of the day. So, in this case, this again is in Dorset, you're looking at the contours as they should be at the end of the life of the quarry. So you should know what it's going to look like before you start at the end of it. Actually, in this case, there's quite a bit of latitude to do different things if you were to encounter a better quality sand in one area than another. But nevertheless, there is a plan, is what I'm saying. And why do we do this in this case? Why are we doing it on Dorset heathlands? Because southern heathlands have a unique suite of flora and fauna because they're very dry, because there's high levels of sunshine, they're warm, they're free draining. You get this whole suite of animals that thrive there. So you've got the top middle, you've got the smooth snake. Only occurs really down here. Smooth snake's main diet is sand lizards to their right. So they sort of coexist, but one eats the other. The smooth snake is a constrictor. The sand lizard's a male, really quite vivid green, quite a spectacular animal. And there are big populations of these. If you actually look how many there are per hectare, it could be hundreds. I mean, there's lots of them. You might not see them, but they're there. Then you've got the Dartford warbler here, which again doesn't survive well in a cold winter, so it's looking for this sort of environment. There's the nightjar down here, another heathland specialist, and on the left that's the silver-studded blue, whose larval food plant is heather. So sometimes you have to think, what's the objective? What are we trying to achieve at the end of the day? And what we're trying to achieve is a habitat which supports these comparatively rare animals. I say a bit more for the engineers. This is the best way of relocating turf. So if you've got a donor site, maybe something that's being commercially or industrial developed, which is heathland, you can literally take the turf up in 2.4 by 1.2 meter slabs, put them on a little truck, transport it to another site, put it down, and it will do fantastically well. Now, clearly there isn't enough donor sites to recreate heathland, but where you can, it's a superb way of doing it. It's commonly done on calcareous grasslands and all sorts of things now. It works. If it's done properly, it works. And there's an example. There's the heather turfs. Heathland turfs have been in the process of being put down. Just checking the time here. Yeah. This is creating a hay meadow. If there's any farmers there, you're going to be shocked because we're going to take a perfectly good field and we're going to take the soil off it, and then we're going to rip it and we're going to chain harrow and seed it with a calcareous hay meadow mix. So this was back to the Balladon quarry where we got a specific objective to make hay meadow because they're rare in the Peak Park and we get good karma from the Peak Park Planning Authority for doing it. So we've actually taken off the nutrient-rich soil, mixed it with scalpings and put it somewhere else on the site, given it some drainage with that ripper, and then plant it. And what's the result? The result was great. The result was great. It's a beautiful hay meadow. That's meadow cranespill is the blue flower, and you can see here these yellow fellows here, vital in a hay meadow. Rhinanthus minor, the hay rattle or yellow rattle, and that is parasitic on grass roots and encourages the suppression of the grasses and therefore the wildflowers coming up. So that worked really well in doing that. Just a couple of minutes on trees. This is the slide which I'm talking to quarry managers. I say, if you go home and just remember one slide, please remember this. If you're planting trees, plant native ones. Why? Everyone tells you to plant native species. Do they really tell you why? Well, there's why. The oak, associated insect species, 284, 400 odd if you count the microflies. Willow, 266, birch, 229, horse chestnut, 4. I rest my case. You know, these trees and shrubs have been around since the Ice Age, and insects and bryophytes and fungi have adapted to them and grown on them and whatever, and you know, forms the whole building blocks of the ecosystem. So hugely important for hedgerows and for woodland. And just to hammer the point home, this is a much unloved species, the leaf miner. A leaf miner lives its whole life, or three of its 4 cycles anyway, within a leaf, a bit like working in credit control. And then there they are. There's the larva down here. There's the frass. There's another word for frass, but not on this presentation. You can see these little lines where it's been running through the leaves. So these tiny little micro moths, the larvae are the food of the birds and other insects parasites and whatever. So sycamore, a couple of species, oak and bramble, dozen species, birch, 3 dozen species. So if you're planting the native trees, you get the larvae that use them at base of the ecosystem. And woodland, a lot of people talk about planting it. Yeah, great, but they've got to have an understory as well. They're not an old-fashioned, good quality woodland until they've got an understory. So in this case, this is Ballon Quarry again, actually. We've thinned out a lot of these ash, and we're planting holly and hawthorn and rowan and whatever underneath to give it an understory. And when you do that, do leave all the brash lying around to rot down for the fungi and boring insects which would go into it. Don't do this, which is incorrect. Also one of my sites, I'm afraid to say, where we mash the understory up. Okay, I'm going to finish now with one of my favourite projects. I'm going back to the 80s now. This is Lydd. Anyone who's been to Lydd at Dungeness, second most visited RSPB reserve is Lydd. And Lydd Bird Reserve had a working gravel pit within it. Okay, so that's the RSPB had a working gravel pit within it. And you can see here, we've got these early ones, these very unnatural straight lines of a gravel pit. And then we go on a bit, and we've got these sort of slightly less unnatural lines of a gravel pit. And then we get to this area here, Walker's Outland, which is a whole series of wetlands and reed beds. And this is the visitor centre here if you ever go there. And this is a story of, I always think industry working with charitable bodies. When I went to Lydd, they were trying to make islands out in the lake, and a couple of guys, volunteers, would row out in a rowing boat with about 6 bags of gravel, dump them, and they do this for weeks on end, and then a storm would come along and take it away. And we worked out that if we dredged the bottom of some other lakes, when we had a dredger on site, we could actually pump up thousands and thousands of cubic meters of waste silt and make islands, and then cap them off with some gravel, which we did with a dredger like this. And it was immensely successful. And if you go to the visitor centre today and look out, those are the islands. They're full of nesting, terns and all manner of bird life are there. And that's when business and conservation, get on and pull their resources. We're getting right to the end now. This is a close-up of the Walker's Outland thing, where the RSPB said, we don't want any more open water, we want reed beds and shallows. So we actually dug out individual quarries and then pumped back the silt I talked about earlier into them, which is where we got the idea from. And you can see you've got this whole series of little islands and reed beds and scrub, and it's a fantastic area for for the wetland birds. Let's finish off. Last slide. This was just a nice picture. We started with a nice picture, we had one earlier of the rock. This is a bit of land next to a quarry, which hadn't been worked yet, and the farmer was off it. And we thought, well, rather than just leave it as it is, let's plant. This was the 100th anniversary of the armistice. Let's plant a whole load of poppies and wildflowers, disturb the ground and put these in and make this fantastic display as a celebration of the end of the First World War. And the cost of that was really, quite modest, but it just looked fantastic, and local people came to look at it. Thank you very much.
Thank you, Andy. That was a really, really interesting, rapid tour through quarrying, quarries, biodiversity. Fantastic. Now, if people have any questions, we've only got a small amount of time, but if you have a question, put it in the chat. And while you're thinking about that, I've got a little sort of comment question that I might just make, Andy. You sort of talked about two parts for me. The first part, I think the technical phrase, the abiotic part, where you're restructuring the landscape really, and doing something actually to change even the soil chemistry and all those things. And then the other part of what you talked about is introducing or encouraging biodiversity to take hold. Yeah, so there's sort of two steps. And I was thinking, well, what can we this is my question, what can we learn from the quarrying experience, and your own in particular, that would help us deal perhaps with some of the grade 4, even grade 5 degraded upland landscapes? Yeah. Which I have to be sensitive, but let's be frank, they're not very productive for food, quite a lot of them. And there are people who are encouraging wilding of them, which is just let go and see what happens. Maybe there are things we could learn about interventions you've made in quarrying that would be sensible and effective for those upland grade 4 and 5 sites. Any thoughts?
Sure, that's a curveball, Mike.
Well, it seems to me an important question.
Yeah, no, absolutely. I mean, obviously,
there was an example where you, which for a soil scientist, of course, is basically a very serious offence, where you strip the soil off, but in order to create new meadows, that kind of thing. Maybe even reprofiling some things, because at the end of the day, in the uplands, there have been a lot of small quarries over the years. Different things have been introduced.
Yes. I mean, the fact is, these are the candidates for rewilding, really, because they're, as you say yourself, they're only really there because of subsidies for sheep. Sheep are not good news for conservationists, because there weren't sheep thousands of years ago. They're not natural to the British landscape. So I suppose the answer is
unless you've got a beautiful chalkland.
Indeed, that is a specific
site in Dorset. We quite like those sheep.
Yes, and you got to have that. But I mean, you could, of course, if you can get at the soil, you could strip most of it off and rewild it, and then create maybe half the farm as productive with a thicker soil, and leave the rest, to go with a much thinner soil. That's a completely, off the bat sort of answer.
Yeah.
Yeah, that's certainly possible, and probably disturb the ground as you did it to bring some nutrients up. But don't really have an answer to that, Mark. I'm sorry. I'd rather be honest.
Okay. More research needed, obviously.
Yes,
Right.
indeed.
We have a question. Andy, are you familiar with College Lake near Tring in Hertfordshire? This is one of the first quarries to be restored in the way you've been describing. Do you know this one?
No, I don't. But far away.
Well, the question is, do you know it? And I
No.
guess if it's at Tring, it's probably a chalk or
Yeah,
limestone chalk quarry, is it?
it's actually, it was Blue Circle Cement
Ah,
who
okay.
extracted it, and it was due to be restored to agriculture. But one of the employees said, well, actually, wouldn't it be better to make this a wildlife area, because we'd got the scrapings from the soil initially would put into a storage area, and they noticed that when they disturbed it, you got species coming up that were locally very rare because they'd been stored for 30 years. So no, I'm just interested if Andy knew of that, because I forget, it was probably 40 years ago maybe that we visited that. But does that predate when you were first doing things, Andy?
I was first doing things in the early 80s, but I didn't really cover, other than that dew pond, ponds and lakes in the presentation. I deliberately took them out and put the yellow metal in. But again, there's a whole genesis to gravel pits in particular. The first ones, they dig a hole and they left it, and the sides were pretty much vertical, and the trees they planted were often ornamental. And vertically sided gravel pits, even though they're only 2, 3, 4 meters deep, are just nowhere near the value of something that's got a very shallow side, and has got reed beds and whatever like that, softening it. So you can really see what the first ones look like and how uninteresting they are compared to what's done today. So if you're making a lake from a gravel pit, there's a few things you need to do. You need to have these very shallow sides, have some steep slides, but shallow areas under a meter deep, so they'll become reed beds and protect the sides. You need to put soil back actually on the base before you come out of it. So you need to pump it dry and make sure that happens, because more will grow into the soil than nothing, particularly around the reed beds. And then, if possible, you make as many islands as you can. And there's a lot of examples now where those islands, they put a membrane on and then cover them with gravel, and you get little ring plover, which is very rare. It's one of the few species of birds who have actually increased considerably, and it's increased considerably because of gravel pits. So there's a lot of management you can do, which we've got to over the years. And of course, an awful lot of ponds have been created for newts, because if you have newts on site, you have to create them new ponds, you have to create twice as much area as you had originally. And again, they tend to be, very shallow places as well.
Yeah.
Well,
Okay. Thanks
well,
very much.
thank you very much, Andy. I think it being around 2 o'clock, we do need to bring this to a close, which is a shame because there's so much we could go on discussing, and such rich material that you've brought for us, Andy. As an institution, we're really grateful to you to take the time you've taken to prepare this, the time to present it. We hope you'll keep in touch with us. We're quite a friendly institution, and we like friends like Andy Littler to keep in touch with us. So that's
Well, I what I do in retirement, which but the other people won't, Mark, is I'm still offering free advice to quarry companies, and to the local golf course at the moment who are building a pond. And if any people there want any advice, if they want to email me or telephone me, or they want information on anything specific, then just go ahead. That's what I do these days. So I'm just
Thank you
committed
for
to
that.
better practice in this
And that's
business.
really useful for
Yeah.
for our members, I think, too. Can I just also say thanks to Engineers Ireland for joining us, because that's an important thing for the institution as well. But overall, thank you, everybody. Special thanks to Andy again. Thanks, Sarah, for calmly managing Andy and I through the morning.
No thanks to BT.
Yes, well, they disconnected me in West Dorset. They disconnected me halfway through the Spain-England match. Anyway, I went for compensation afterwards. I've got some compensation out of them. Anyway, thanks everybody, and thank you, Sarah. Thank you, Andy. Thank you, everybody.